Another generalization of the idea of derivative is the so-called directional derivative. The idea here is, say we're looking at a function of two variables, x and y. So the partial derivative with respect to x takes the limit as delta x is going to 0. So what's happening is we're moving in toward our point xy from the left and from the right. So this you can think of as the partial derivative with respect to x. Partial derivative with respect to y tells us the change as we move in along the y direction. So that would be the partial derivative of f with respect to y. It's sort of the slope as we move along in the y direction is the partial with respect to y, and the slope, the change in the altitude as we move along in the x direction is the partial with respect to x. There's nothing stopping us from moving along in some other direction. Say we come in along this direction over here, we come in along any angle, and that gives us the idea of directional derivative. And this is usually denoted as d with the subscript of u and f, where u is a direction vector or a unit vector. So you take any vector of length 1, and we've got this formula for directional derivative. And what that is, the directional derivative in the direction of u with a function f. If we look at just x and y for now. Well, first we're going to think of xy as a vector. And this gives us the limit as h goes to 0 of f of, well, treat that xy as a vector, plus h times the direction minus f of x all over h. So this is the directional derivative in the direction u. Let's maybe see an example of this. Let's say we have u is the vector 1/2 radical 3 over 2, and our function is, let's say, x plus y squared, and we want to know the directional derivative of f in the direction u. So what we have here is limit as h goes to 0. Now our function is x plus y squared, but what we're adding to this, let me write this in. Well, let me write it out. This is f of x plus h times our first component, and then y plus h times our second component, minus f of xy all over h. So what we've done is we've taken x and we've added onto it h times the vector u. We subtract the original function and we divide by h. So if we fill in what our actual function is here, this gives us the limit as h goes to 0. Well, f of x plus h times 1/2, we're going to plug that in, and we get x plus 1/2 h. Plus, we take y squared, so we're going to square this, is y squared plus radical 3 hy plus, we square this term, and we've got 3/4 h squared, minus, we take just subtract the original function, so x minus y squared. And this is all over h. So now we're going to look for terms to cancel. So see, we've got a positive x and a negative x. Those wipe out. We've got a positive y squared and a negative y squared. And it looks like everything else has an h in common, so we can factor it out. This gives us limit as h goes to 0. We factor an h out of the numerator, and we've got 1/2 plus